Hi, this is Akshay with another numerical problem, and once again this numerical problem will take into account the concept called heating effect of electric current. Let us go through that kind of a statement which is already given here. 100 joule of heat produced. It's given that heat produced is 100 joule in each second is the time in a 4 ohm resistance, and the 4 ohm, it is the resistance given. Find the potential difference across the resistor. So let here it is the representation for the resistor, and its resistance given, it is 4 ohm, and 100 joule of heat is being generated, and it's gonna be heat H is equal to 100 joule in each second, and it is given that time is equal to 1 second. In time 1 second, each second means 1 second. In a 4 ohm resistance, find the potential difference across the resistor. Obviously all that's happening over here is happening under the action of potential difference, because it is the potential difference which makes the charge to flow through one end of the resistor to the another end of the resistor. So here it is. That's what the question is all about. You need to find out the potential difference. This is going for a question mark. Here it goes this way. It is. So V is the potential difference, and this is what we are in search of. And obviously when the potential difference is applicable or applied to a resistor, current is certainly going to flow through it, and that current when travels through this very resistor having resistance 4 ohm, it is being mentioned that heat is gonna be generated equivalent to 100 joule in 1 second. So we need to find out V. How to proceed in this very numerical problem? In order to find out V, yes, according to Ohm's law, V is equal to IR. So let us chalk out a roadmap here. That is what to do over this very numerical problem. V is equal to IR. That's what we know. V is equal to IR. It means in order to find off voltage or potential difference acting across the resistance 4 ohm, we need to find out how much current flows through that very 4 ohm resistor. It means the point is to find out I. So that's what we need to find out I. So clearly we are knowing our target. We need to find out I. Once we know the I, R is already there. We can calculate how much the potential difference is applicable across the ends of a resistance 4 ohm. But in order to find out I, we need to use other physical quantities here. It is given here that heat is equal to 100 joule. Oh yes, it leads directly to the heating effect of electric current, which says that H is equal to I square RT. H, it is given. Time, it is given. Resistance, it is already there. You will find out how much current is gonna be generated. So this very, you can say, a portion of heat will give us current I. Once we know current I, we can put this formula into play and find out what is the voltage acting across the resistance 4 ohm. So by now you know what to do. And firstly, we are going to find out heat produced, but we are going to find out current traveling through this very resistance, and thereafter we will put the value of current in V is equal to IR. We are going to have the voltage there. So that's how we will proceed in this very numerical problem. So let us do it. 100 joule of heat. This is given here. 100 joule of heat. So there you are. Heat produced. 100 joule produced in each second. This is time. Each second means 1 second. A 4 ohm resistance. This is resistance. For ohm. Find the potential difference. That's the question. Potential difference V. That's going for a question mark. Question mark. Okay, by using these values, we are going to find out firstly what is current. I have told you before. So here we are going to apply this very formula straight away, since, or as we know that H is equal to I square RT. We have learned it before. H is equal to I square RT. H is given to us, R is available here, time is given. We need to find out I here. So we will keep I one side and I square on the one hand, and others are going to be transferred to the other side here. Or I square is equal to, it's H and this is RT going towards the denominator of H. Here it is, and it becomes H upon RT. Or I square, let us put up the values of each and every physical quantity here. H is 100 joule, it is 100 joule. Resistance R, it is 4 ohm, multiplied by time, it is 1 second. Let us solve it. 1 and it is 25. Or I square is equal to 25 joule upon ohm second. And remember, joule upon ohm second is equal to ampere square. Or I square is equal to 25 ampere square. And if you want to know that is how joule upon ohm second is equal to ampere square, let me tell you over here. Here it is. Here it is joule. According to, you can see that definition of potential difference. You know the definition of potential difference. It is equal to, potential difference is equal to work done upon the quantity of charge. And in case of unit, you will write it as volt is equal to joule upon coulomb. Or it can be written as joule is equal to product of V and C. Here it is, in place of joule, we are gonna write it as VC. Here it is ohm. You know the unit ohm is of resistance. And the resistance is equal to V upon I. And resistance, it is ohm, unit V volt, and I, the unit of electric current is ampere. So in place of ohm, we are gonna write it as volt upon ampere. Here it is, volt upon ampere, and second remain as it is. You know, volt and volt cancel straight away. This ampere goes in the, you can say, goes towards the numerator, and it is equal to coulomb, and here it is second, and over there it is ampere. And this is also well known to you, that is coulomb upon second is equal to ampere. Ampere multiplied by ampere, and it will give you ampere square. Here it is. So this joule upon ohm second is equal to ampere square. So that's what I have put over here. I square is equal to 25 ampere square. There you are. I square is equal to 25 ampere square. Now we are going to find out I by taking square root here. Therefore, I is equal to plus minus 25 ampere square under the root. Or I is equal to plus minus, it is 5 and it comes out to be A. So either, yes, either I is equal to plus 5 ampere or I is equal to minus 5 ampere. We will reject this value because current can't be negative. Rejecting this value since current can't be negative. So therefore current I is equal to plus 5 ampere or simply 5 ampere. That's the current. So once we know the value of current, now we are in a position to find out the voltage. So since we know that V is equal to IR, time has come to find out the voltage. V is equal to IR, put the value of I, that's 5 ampere, and the resistance is already known to us, that is 4 ohm. Or V is 5 ampere multiplied by 4 ohm. And it comes out to be V is equal to 5 for 20 ampere into ohm, that comes out to be volt. Therefore, yes, therefore potential difference or voltage V is equal to 20 and ampere into ohm is equal to volt, or why ampere into ohm is equal to volt? Because we know that is V as far as ampere multiplied by ohm is equal to volt. And you know why it is equal to volt? Because of the reason that in case of ampere you will put the value of ampere. Yes, that is what we are gonna find out, that is a ampere into ohm is equal to volt. Why? Because in case of ampere we will write it as ampere, and by using ohm is equal to volt upon ampere we will write here in case of ohm volt upon ampere. Ampere cancel, that shows that is ampere multiplied by ohm is equal to volt. So there you are, potential difference V is equal to 20 volt, which is acting over here across the ends of 4 ohm resistance. And that's all about this very numerical problem. That's it here.